Hi everyone, today we would be looking at hashing in system design. In the previous video, we have already talked about load balancers and how the algorithms in the backend of the load balancers work. But it's very important to know about hashing because if you guys have studied about basic data structure algorithms, hashing function is not a very complicated function for you guys. For people who don't know about it, I will just give a real life example to explain hashing. So let's consider a scenario that we have a library. We are in a massive library. Now this library will have millions of books, let's say 2 million books. So and we are tasked with finding a specific book titled The Art of System Design. Let's say the book name is ASD, Art of System Design. Now without a system in place, searching for this book would obviously take it's like taking a needle in a haystack. Now you could go through every single book. The library would look something like this. You would have infinite number of columns because 2 million books are there. So one way, you can go through every single shelf row by row, book by book, until you find the book you are looking for. So this method will take an enormous amount of time. But then comes the hashing function to help you. Now I will just take another color to explain you in better way. Then this particular hashing library uses a special catalog machine. Instead of storing books based on their title alphabetically, these machines provide a unique code for every book. So let's say this is the hashing function, and when we search for ASD, there is a unique code for this book, that is 123. Let's say now this calculation is done using a special formula hash function which turns the title into Unicode. You don't need to worry about that right now. Now the library is organized in a way where every book is stored in this hash function and with a Unicode. Now using this unique code, we can actually just search for every book in just 1 second. Just think like that. Now we can quickly go to the exact location where the book is and retrieve it. We don't need to go through every book or shelf. Sometimes we can two different books titles might be given the same code by the machine. So this is called collision. So I think we are good to go with the collision part. But right now we just need to focus on hashing. How it is very important when it comes to in system design, because in system design we have a lot of other things to look at. So we need to focus specifically on storing and retrieving data. Cool. So let's take example of our client server model. It's the favorite thing. These are our clients as usual. Then we have our load balancer in middle, and then we have our servers. Cool. So let's take a very simple example of how things are working here. The requests come here and they go back to the servers. Cool. Simple as that, nothing fancy. Now think like that. A hashing function, from the definition itself, a function that takes in specific data type and outputs a number. Different inputs may have the same output, but a good hashing function attempts to minimize those collisions, as I told you. Now suppose this is the name of this is C1, then you have C2, then you have 3, C4, and this is S1, S2, S3, S4. Now remember one thing. Suppose client 1 is again and again requesting for the same thing. Now your load balancer is redirecting it to server 1. Now when server 1 sees that okay, this is a thing that client 1 is requesting, it will cache it in here. It will cache in. But suppose you are working with round robin algorithm. You are working with round robin algorithm for load balancers, like distributing strategy. So when the next time client 1 requests for something, it goes to S4. Now S4 doesn't have that. Similarly, client 2 had something with was redirected to server 3. It had cache, but this time it got redirected to server 1. Server 1 doesn't has the particular cache for that. So it will have to store cache, and obviously it will take much longer time than if it had the cache for that. Here hashing comes into play. Hashing saves the game. Now we can take an example to see how hashing actually mathematically works here. I will again take the example. Let's say you have clients here, you have load balancer, you have server. Now you have 1 client, 2 client, 3 client, 4 client, and then you have A1, 2, 3, 4. And then we have the server here as usual. Now coming to how things work here. Now imagine like this, because we have four clients, and we have four servers. Cool. Now just imagine like that. You need to assign them with a particular value so that every time they are requesting something, they should be redirected to that particular server. Now, so we have four servers. Let's take a value of 12, and let's say 12 mod 4 will give us 0. Cool. Now 12 mod 3, what it will give? Now similarly 12 mod 2, but this is a number which you can't take because it will always obviously give 0. So let's remove it for now and take an example which can actually be used here. So I will take the number as 11. Now you don't need to think how these numbers are assigned, just go with the flow. 11 is being taken here. Now 11 mod 4, what it will give? It will give 3. 11 mod 3, what it will go? 3 3 is a 9, that is 2. Now 11 mod let's say 2, so it will give 1. Similarly 11 mod 1, obviously it will give 0. Cool. So think like this, because this fourth is giving 3, I will just erase this. Yeah, cool. So because this 4 is giving 3, so we need to make sure that this particular server is redirected here. Now just imagine for now client 1 is taken as 4. I have taken client 1 as the fourth here. This number 4 is here and it is giving 3. So technically client 3 should go every time to server 3. It should redirect me to server 3. Whenever client 4 comes, it will mod it from 11, get the result, and it will give me to 3. So this is going to improve my strategy because the load balancer is going to work this way. It will say, okay, client 2 has come. I will quickly mod 11 mod 2, that is equals to 11 mod 2 is equals to 1. So my client 2 should always go to server 1. It should always go to server 1. So this is like how a hash function will work here. But let's imagine a situation where a fifth client comes and a fifth server comes. Now in this case you will definitely increase it by 5, but now it will give 11 mod 5, that is equals to 1. But 1 was for this, 1 was for 2. Now things will get difficult here. So from this we get to know we need a very robust hashing function. We can't take any hashing function. We need to have a very robust hashing function. But the good part is, in system design, you don't need to actually worry about the working or algorithm of a hashing function. You can just say any hashing function. Like there are very famous hashing functions. Like one is consistent hashing. Then you have rendezuous hashing. Then you have SHA. Then you have MD5, and then let's say one more. Let's say NTLM. So like these are very famous 5 hashing functions algorithms. These 2 are the specific algorithms. These are provided. You can just go and have a look on Google. So yeah, this is exactly the part for hashing. If you guys just wanted to know about this, you guys can end the video here. But if you want to know about how one of the function works, I will just show you a very basic example. I will take the example of consistent hashing. So let's take a cycle here. Cool. Now in this cycle, you have let's say you have a lot of servers. You have server D, you have server A, cool, you have server B, and then you have server C, and cool, then you have client 1, then you have client 2, then you have client 3, and then you have client 4. Now how these things work here? In consistent hashing, the client will actually respond to the nearest server that it has for hashing. That is, C2 will be responsible for will be going to A, C1 will also be going to A. Now client 3 will go to B, client 4 will go to C. So it's pretty simple here. But just imagine that worst case again happens. Suppose this server A dies. Now what will happen to C and C1 and C2? They will go to B. They will go to B. Or we can have a much better alternative. As soon as server A dies, we can replace it with a replica of server A, or let's say a fresh replica of E. So only C1 and C2 will get affected, not all the other functions C3 and C4. This is a very basic example of how consistent hashing works. So yeah, this was it from my side for this video. I hope you guys have got an idea how hashing works and why it is very important. Now in the next video, we are going to talk about databases, like what are relational databases, what are non-relational, SQL, no SQL, something like that. So yeah, that was it from my side. Thank you and have a nice day.